Welcome back to the deep dive. So if you're like most people, you are just constantly consuming information, articles, news, research findings. But how often do we really stop and, evaluate the source?
hmm
We talk a lot about knowledge, but what are the actual fundamental rules for creating reliable knowledge?
And that's exactly our mission today. We're sort of skipping this specific breakthrough and diving straight into the blueprint.
The how-to.
The how-to, exactly. We've pulled out the core principles of what makes any investigation reliable from a pretty foundational text on research. The whole goal is to give you a really clear, systematic way to understand what separates, say, a casual inquiry from truly structured, valid research.
So we're basically handing you the ultimate BS detector. By the end of this deep dive, you'll have a kind of map of the criteria and the classifications that structure all intellectual work, and that should help you instantly assess, how trustworthy the data you see every day actually is.
I like to think of it as defining the integrity of information. We'll start with the general characteristics that all research should have, and we'll drill down into the three non-negotiable gold standards, the criteria for good research, before we map out the main ways it's all categorized.
Okay, let's do it. Let's unpack this and start with those foundational characteristics. When experts define research, they highlight a few key elements. Which ones are the absolute must-knows for the listener?
I think four really stand out, and it starts with the source material itself. Good research has to aim to gather new knowledge or data from primary or first-hand sources.
Right.
If you're just reading someone else's take on it, you haven't done research. You've done a literature review. You have to generate something new.
That makes perfect sense. You have to get your hands on the raw material, and once you have it, it has to lead somewhere useful, right? The text says it needs to emphasize the discovery of general principles.
Absolutely. It's not just about finding one tiny data point for one very specific case. It's about asking what that data point tells us about the wider world or the bigger phenomenon. It needs to be generalizable.
And you can only generalize if the whole process is, rigorous. The source material describes it as being inherently systematic and accurate, and also logical and exact.
Right.
That systematic part, it feels like the barrier that stops random observations from being passed off as serious findings.
Precisely. If you can't lay out your path clearly, you haven't been systematic. But I think the most critical characteristic, and maybe the hardest for us as humans, is that the researcher must eliminate personal feelings and preferences.
Okay, that's the big one for me. You can't start with the answer you want and then try to bend the data to fit it.
Yeah.
But how realistic is that, really? We're all driven by curiosity, by our own experiences. Doesn't trying to eliminate personal feelings risk-making research sort of sterile, less human?
It's a great question, but the goal isn't to eliminate humanity. It's to eliminate bias. That requirement for impartiality, getting rid of personal feelings, that is probably the single most defining piece of intellectual integrity. When you're systematic, when you're accurate and logical, you are actively, intentionally removing your own subjective influence from the objective observation.
So the process is systematic, the motivation is impersonal, which I guess leads right to the final point.
I think so.
Research is a patient and unhurried activity.
It has to be.
You just can't rush the removal of bias or the rigorous application of a method.
Exactly. And that's why we trust it.
Yeah.
When you see research that's been verified, the people behind it have followed this path. They've avoided the shortcuts. They've avoided their personal inclinations.
Okay, so let's move from the general rules to the gold standards. If those are the general characteristics, there are three non-negotiable criteria that define good research. The three pillars that, let it stand up to scrutiny.
Right, and the first pillar is just a natural extension of what we were just saying. Good research is systematic. Perfectly put. It means the investigation is structured. There are specified steps, you take them in a specified sequence, and you follow well-defined rules. It's like having a detailed recipe versus just, throwing ingredients in a bowl.
And this is where the quality really starts to show. The text points out that while, creative thinking is absolutely essential, you need it to design a good study, the systematic nature means you reject using guesswork or intuition to get to your conclusions.
Yes.
You can be creative in the method, but you can't be creative with the final interpretation.
That is a vital distinction, which leads to the second pillar. Good research is logical. It has to be guided by the rules of logical reasoning, and specifically, it uses two main engines, induction and deduction.
And this is where it gets really interesting. For clarity's sake, if we just forget the academic jargon for a second, how should someone think about induction and deduction? We need a simple way to remember it.
Okay, let's use the simplest example I can think of. Think of induction as scaling up your observation. You're reasoning from a part to the whole.
Okay, give me an example.
So if you randomly pull 100 bags of potatoes from a huge farm, and you find that 95 of them are perfectly healthy,
You assume the whole crop is probably healthy.
you induce that the entire crop is healthy. You've used specific examples to create a general rule. It's the basis for, all polling, most field work.
So induction sort of creates the rule, which means deduction is the opposite.
Deduction is just applying a rule you already have to a specific case. You reason from a premise. If your general premise is that potatoes from this farm are healthy, and you pick up one specific bag.
You deduce that the potatoes in that bag are also going to be healthy.
Exactly. You move from the general truth down to the specific conclusion.
I love that. So induction builds the theory and deduction tests it out. And using both logically is what makes research meaningful, right? Especially for decision making.
You need both. You absolutely need both. You need the general principles to frame your problem, and you need the specific testing to see if those principles still hold up.
Which brings us to the third and I think most vital pillar. Good research is replicable. Why is this the ultimate acid test?
Replicability is how knowledge becomes solid. It just means that if another researcher, someone totally independent, follows your exact systematic logical steps, your methodology, they should get, substantially similar results.
So if I discover some groundbreaking effect, but nobody else on Earth can repeat my experiment,
Then your effect doesn't really stand up.
it's immediately suspect.
Immediately.
Right.
Replicability is the key to building a sound basis for any decision. If you can't reproduce the results, the first finding might have been, an anomaly, a statistical fluke, or worse. We've all seen those high-profile studies get retracted in the news because other scientists just couldn't get the same outcome.
Right. So knowing a study is replicable means its foundation is solid. It's the ultimate quality control.
It is.
Systematic, logical, replicable.
Mhm.
Okay, that's the framework. So now let's shift from quality control to methodology. Once we agree on the rules, how do we start categorizing what we're actually doing?
Well, the easiest way is to think of research in terms of core contrasting pairs. If you can understand these three pairs, you can pretty much map the entire research landscape.
Okay, let's start with the first one, descriptive versus analytical.
Descriptive research is, it's pretty much what it sounds like. It's concerned with just describing the state of things as they exist right now. It's all about answering what is. A census is a perfect example of descriptive research. It's a snapshot.
And analytical.
Analytical research takes those descriptive facts, that information that's already out there, and it analyzes them to make a critical evaluation. It goes beyond the what and starts asking why or how.
So descriptive research tells you unemployment is, say, 4%.
And analytical research would use historical data and economic models to critically evaluate why it's 4% and what that might mean for the future.
That's a crucial distinction for anyone just, reading a report. Am I just being shown the numbers, or is someone trying to interpret and evaluate them for me?
Exactly. Which brings us to the next major pair, and this one really highlights attention in academic work. Applied versus fundamental.
Applied seems pretty obvious. It's practical.
It is. Applied, or you could call it action research, is all about finding a solution for an immediate problem that's facing a society or maybe an organization. It's all about intervention. Think of finding the most efficient way to deliver vaccines to a rural area.
That's urgent. It's practical. So what's fundamental?
Fundamental research, or basic research, is more concerned with generalizations and building theory. It's really about seeking knowledge for its own sake. Think of a biologist studying some rare protein in a deep-sea creature with no idea if it will ever cure a disease, but just doing it to understand life a little better.
And that's the classic tension, right? The policymaker who needs a fix today versus the academic who's pursuing a deep theoretical understanding that might not pay off for 100 years.
It's a necessary tension, though. The applied researcher is often using the theories that the fundamental researcher built. And the fundamental researcher is often inspired by the real-world problems the applied researcher is trying to solve. They feed each other, even if their timelines are totally out of sync.
Okay, let's hit the last major pair, conceptual versus empirical. This feels like the split between, I guess, pure thought and pure observation.
It's spot on. Conceptual research is all about abstract ideas or theory. It's what philosophers or, deep thinkers use to develop new concepts, like a new theory of justice or maybe to reinterpret old ideas. It happens entirely in your head.
And empirical research is the opposite.
Empirical research relies strictly on experience or observation alone. It's all about getting out there and gathering raw data, sometimes without even thinking about how it fits into a grand theory. It is purely data-driven.
So conceptual research is building this elegant theoretical structure.
Yes.
But empirical research is sometimes just looking at the raw data and saying, hang on, that doesn't fit your theory, but it is what we saw.
That's a perfect way to put it. It's the difference between studying what justice should be, which is conceptual, and counting how many people feel like they've been treated justly by the current system, which is empirical. You need both, but they start from completely different places.
Okay, so we have the three big pairs: descriptive analytical, applied fundamental, and conceptual empirical. That covers the major divides. But the source material also touches on some other ways to categorize research. We don't need to spend a ton of time, but what are the most relevant ones for you?
The others are really useful variations, often based on specific constraints, like time, or who's driving the whole thing. For instance, if you classify by time, you get one-time research versus longitudinal research.
Where you follow the same people over a long period.
Exactly, which is so important because you just can't capture change with a single snapshot. And then there's classification by objective, exploratory versus formalized. Exploratory is that initial stage. The only objective is to develop hypotheses. You're just trying to figure out what questions you should even be asking.
You're mapping the terrain.
Right. Whereas formalized studies are super structured. They're designed with specific pre-existing hypotheses that need to be tested. You already have your educated guess. Now you're going to put it through that whole systematic, replicable process we talked about.
And finally, the classification based on who's in charge of the research. This one defines the researcher's freedom. The source distinguishes between conclusion-oriented versus decision-oriented research. This feels huge for anyone working in, a professional setting.
Oh, it defines your constraints from day one. In conclusion-oriented research, the researcher is totally free. Free to pick the problem, redesign the study if they need to, conceptualize it however they want. It's driven by pure curiosity.
But decision-oriented research, that's for a client or a boss.
Precisely. Decision-oriented research is always, always for the need of the decision maker. If your boss hires you to find out why sales dropped last quarter, you are not free to go off on some fascinating tangent about the history of marketing. The decision maker's goal and their timeline dictates every single step. It defines your scope and your freedom from the very beginning.
That is a massive real-world constraint. It just immediately limits any potential for those fundamental or purely conceptual side quests. The clock's ticking, and the answer has to be applied.
It summarizes the whole conflict perfectly. The need for application often trumps the desire for, theoretical purity.
So let's bring this deep dive home. We've basically established your map for reliable knowledge. You know the three non-negotiable criteria for good research. It has to be systematic, logical, and replicable. And you know the three major contrasting pairs that classify it: applied versus fundamental, descriptive versus analytical, and conceptual versus empirical.
And just understanding those categories empowers you to be a much more critical consumer of information. When you read a report now, you can instantly ask yourself, are they just describing the facts here, or are they analytically evaluating them? Is this a purely conceptual theory, or is it actually grounded in some hard empirical observation?
Okay, so here's the final provocative thought we want to leave you with, and it connects all these tensions. We just talked about that push and pull between applied and fundamental research. So imagine a research team discovers some profound new theoretical framework, something purely fundamental and conceptual that might, redefine physics. But it cannot immediately solve a devastating current social crisis, which demands an immediate, applied, decision-oriented solution. Does the value of that theoretical discovery actually diminish in the eyes of society?
And we also noted that empirical research, sometimes it focuses so much on raw data that it ignores theory, while conceptual research is all about theory. So when that urgent social issue comes along and it demands an immediate solution based only on what we can see right now, forcing a quick, decision-oriented answer, can we ever really be systematic and logical enough to trust that outcome without the benefit of a deeper fundamental theory to guide us? It really raises an important question about whether sometimes expediency has to undermine rigor.
Something to mull over as you see the next big headline. Thank you for joining us for this deep dive into the blueprint of research itself. We hope this knowledge helps you navigate your world a little better.
Until next time.